So we're moving on to the next topic of human impacts, which is resources. So if Ivy was given an option, she could eat the rest of the dog treats in the bag or only eat one and save the remainder for other dogs. What do you think she's going to do? So we're going to take out 2 treats. So Ivy has the option, she can eat one of them and let me have the other one, or she can eat both of them to herself. So let's see what she decides. The look she gives me when I take it away from her. So of course she ate the second treat. So I want you to start thinking about, how is this going to relate to natural resources? So in class, we would have done a similar activity, but with popcorn, and we would pick slips of paper, and certain students would be able to get popcorn first, and they could choose how much popcorn they wanted. So it was up to them if the rest of the class would get popcorn, just like it was up to Ivy if I get a treat or not. So what this is showing is if we have a certain resource, over time we might run out of this resource. But it depends on generations now, how much we're using depends on how much we will have available for the future. So we're going to start looking at the different types of energy sources and if they are readily available or if they are starting to run out. So first we're going to look at the difference between non-renewable and renewable. So non-renewable resources, break it down. So non-renew. So if you cannot renew something, that means it cannot be remade or regrown at the comparison of how it's consumed. So this means that in the future, this is going to run out. If we're using too much, there's not going to be any available for the future. So we're going to take a look at the different types of non-renewable resources. So the first 3 are going to be coal, petroleum, and natural gas. So these are non-renewable because they cannot be replenished in a short amount of time or within our lifetime. So these 3 are put into a group called fossil fuels, which we'll talk about in a second. So coal is typically used today for electric power. Petroleum is typically used for heating or manufacturing, and natural gas, same thing, heating. Petroleum is used for cars as well, natural gas, transportation, etc. So what are fossil fuels? They're just as they sound. So they're from fossils. So over time, fossils under heat and pressure, they're going to become coal, oil, or gas depending on what types of organisms are being fossilized. So how is coal made? So coal is going to be a bunch of dead plants that have been buried over time, and under heat and pressure, this will eventually turn into coal. So coal is going to specifically be made just from plants. So this is what's going to make it different from petroleum and natural gas. So how are oil and gas made? So these are going to be a combination of plants and animals that have died over time. So depending on the amount of each is going to depend if it's oil or gas that is formed. So it's going to be the same process. So over time, these organisms that have died are going to be buried, and then under heat and pressure, it's going to form this oil or gas. So an easy way for me to remember, it's a little bit silly, but think of like passing gas. So Ivy passes gas all the time, and I think of she's an animal. So gas is made from dead plants and animals. So that's one way that you can remember how gas and oil are different from coal. So what is the difference? So coal is made from plants, oil, gas made plants and animals. So don't forget that. All right, so how do we actually extract these things? So coal, you're going to have to mine for it. Petroleum is drilled from the ground. So petroleum's actually easier to get out of the ground because it's liquid, and it also can flow in pipes a lot easier. So it's also cheaper to transport. Coal, on the other hand, it's a very messy process, but coal itself is extremely cheap, just not cheap to transport. So thinking about fossil fuels, so once we burn them, they will not be there anymore. So almost every 20 years, we're doubling our consumption of fossil fuels. So eventually we are going to run out. So the last type of non-renewable source is going to be nuclear energy. So nuclear energy works with nuclear fission, which is splitting atoms, and specifically it's used with uranium and plutonium. So this is non-renewable because uranium, plutonium, they're metals, and once these metals have been mined to the point there is no more, then this resource is gone. So how do we get the nuclear power? So as I said, it's a metal, so we have to mine it. So it's a very dangerous process, and it's very harmful to the environment. So it's not a very good choice. Nuclear power makes up about 11% of the world's energy.
Are non-renewable energy resources. These are coal, oil, and natural gas. They were formed from the remains of living organisms millions of years ago, and they release heat energy when they're burned. This heat is used to turn water into steam, which is used to turn a turbine, which then drives a generator to generate electricity. This is the standard model for a power station. There are downsides, however. Fossil fuels release sulfur dioxide and carbon dioxide, which leads to acid rain and an increase in global warming. Another form of non-renewable energy is nuclear. The main nuclear fuels are uranium and plutonium. The nuclei of these large atoms are split in a process called nuclear fission to release a great deal of heat. The heat energy is again used to boil water. The kinetic energy in the expanding steam spins turbines, which then drive generators to produce electricity. Unlike fossil fuels, nuclear fuels do not produce carbon or sulfur dioxide. However, they do have the risk of a fault where large amounts of radioactive material could be released into the environment, such as the disaster of Chernobyl in 1986.
So I thought this was an awesome review to go over all of the non-renewables. So one thing we didn't talk about was how it actually works. So it's pretty awesome that it heats up water, that steam is going to turn a turbine, that's going to turn a generator, which is then going to create electricity for us. So it's a really interesting process. So if we call it non-renewable resources for those that cannot be remade at a scale comparable to the consumption, renewable resources are going to be those that can be replenished in a short period of time. So we're going to look into solar, wind, water, geothermal, biomass, and tidal. So we're going to go through these in the next slide. So the first renewable resource is solar power. So why is this renewable? So solar is from the sun, and the sun is not going to burn out anytime soon, not for millions of years. So it's always going to be readily available to us. So how does solar power actually work? So there are photoelectric cells and solar panels that are going to convert light energy into electricity. The next renewable source is geothermal. So this is going to be heat from the earth itself. So why is this one renewable? So the earth, yet again, is not going to go away anytime soon. The earth is at a certain temperature in the core, and it's not going to cool down anytime soon. So we're always going to be able to get that energy from the center of the earth. So in order to get this one, you need to drill down into the rocks to release the steam, and it's going to go through that same process as we talked about before, moving the turbine, etc. So the next one is wind energy. So this one is renewable depending on the area that you live in. So for me, it might not be the best resource to have by my house, but if I lived somewhere like Waterford, New London area by the water, then there's a lot more wind current in that area. So why is it renewable? So you've definitely learned about this before, the convection currents in our atmosphere. So there's going to be patches of warm air rising, cold air dropping down, and this is going to be creating those wind currents that we can feel. Wind power has been all around for a super long time, so at least for 4,000 years that we know of. So the Babylonians and Chinese used wind power for water pumps and also to grind things like corn. They also had sailboats long before this, so they were using wind power for transportation as well. Then we have biomass. So biomass is just how it sounds. So bio, like living things. So this is going to be energy from burning organic or living matter. So why is this renewable? So think of a tree. You get the seeds from it, then you can replant the tree or the bulbs. So these can be regrown, and that is what makes them renewable. So how does biomass work? So plant and animal waste can be used to make fuels such as methanol, natural gas, oil, etc. But thinking about it a little bit easier is like a campfire. You use that to keep you warm, and that's energy. So water or hydroelectric. So we always have water on the earth. It doesn't matter if it's polluted or not, we can still use it as an energy source. So that is why it is renewable. So how does this actually work? So if you look at the picture, you can see they will build a dam to back up the water. Then the water is forced to flow through this tunnel that's going to then turn the turbine, turn the generator to create electricity. So another type of water power is tidal power. So this is going to be as the water moves in and out. So this is extremely useful for water power because it's really easy. It just goes with the flow kind of thing. But the downside is that a lot of organisms can get caught in these tunnels or in these generators and actually die.
Renewable energy resources are being developed because we are running out of fossil fuels at an exponential rate. The wind is produced as a result of giant convection currents in the Earth's atmosphere, which are driven by the heat from the sun. Wind turbines use the wind to drive turbines directly. The blades are connected to a housing which contains gears linked to a generator. As the wind blows, it transfers some of its kinetic energy to the blades, which turn and drive the generator. The advantages are that there are no fuel costs and no harmful pollutant gases are produced. However, they do depend on wind. If there is no wind, there is no electricity. Like the wind, water can be used to drive turbines directly. Wave machines use the kinetic energy of moving water to drive turbines, which then drive electric generators. Another way of using water is to build a tidal barrage over a river estuary to make use of the kinetic energy in the moving water. The barrage contains electricity generators which are driven by the water rushing through the tubes in the structure. Hydroelectric power stations are dams built across a river valley. The water high up behind the dam contains gravitational potential energy. This is transferred to kinetic energy as the water rushes down through tubes inside the dam. Water-produced energy is good because no harmful pollutant gases are produced, and tidal barrages and hydroelectric power stations are very reliable and can be easily switched on. However, tidal barrages destroy the habitat of estuary species, and hydroelectricity dams flood farmland and push people from their homes.
Yet again, I thought that was a really good review of what we have gone over. But what I like best about that is it goes over the positive and the negative side effects from renewable resources, not just explaining that they're amazing. So quick summary, what are the differences between non-renewable and renewable? So non-renewable can't be renewed within our lifetime, renewable can.